So here we want to find all of the angles whose cosine is 1/2. So that's adjacent over hypotenuse, just from our SOHCAHTOA. So let's see, all the angles whose adjacent over hypotenuse is 1/2. So we draw in the the first quadrant and the fourth quadrant. If we draw in the second or third quadrant, then we'll get a negative 1/2. So we don't want that. So these are 1, 2 squared of 3 right triangles. The reference angle is 60 degrees. So in the first quadrant, we would call that just 60 degrees. In radians, that would be pi/3. In the fourth quadrant, we would go almost 360, so we'd be going 300 degrees. Whoops. So that would be 5pi/3. So the 3x needs to be pi/3, or the 3x needs to be 5pi/3, and then our equation will be true. Now that would be just for 2 answers, but there's an infinite number of answers because our terminal side could rotate around the unit circle repeatedly before it lands in its spot. So any coterminal angle is going to make this equation true. So I'll put plus 2 pi k to each of these, and that will capture the infinite number of answers of all the angles whose terminal side lands in either of these 2 positions. Okay, well, let's multiply both sides of the equation by 1/3. So we would have x equals pi/9 plus 2 pi k/3, or x equals 5pi/9 plus 2 pi k/3. So this is an infinite number of answers, and now we're supposed to just find the answers that lie between 0 and 2 pi. So let's go ahead and do that on the next page. So we had x equals pi/9 plus 2 pi/3 times k, and x equals 5pi/9 plus 2 pi k. So we let k take on the values of integers. So k could be 0, in which case x would just be the pi/9, or the x would be 5pi/9. Or k could be 1, and then we would have x equals pi/9 plus 2 pi k, so 2 pi times 1/3. Or over here we would have x is 5pi/9 plus, oh, I lost my over 3 here, plus 2 pi times 1/3. And we can get a common denominator and add these little fractions together. So we'll just take our 2 pi/3s and multiply by 3/3. So we have pi/9 plus 6pi/9, or 7pi/9. Here we have 5pi/9 plus 6pi/9, or 11pi/9. So we have 4 answers so far. Okay, so now let's let k equal 2. So we would have x is pi/9 plus 2 pi/3 times 2, or 5pi/9 plus 2 pi/3 times 2. So that would be pi/9 plus 4 pi over 3, 5 pi over 9, plus 4 pi over 3. And if we get a common denominator of 3, that will multiply the numerator and denominator by 3 here. So I'll have 12 pi over 9, which is 13 pi over 9. Here, if I multiply by 3/3, I would also have 12 pi over 9, so 17 pi over 9. Okay, let's let k equal 3 now. So if k is 3, I would have x is pi over 9 plus 2 pi over 3 times 3. So that's pi over 9 plus 2 pi, and that's bigger than we needed to look. We only had to look between 0 and 2 pi, so we have these 6 answers.